Greetings, math students. We're back. Hope you've had a good break. Hope you're fat from turkey and pumpkin pie and such. I know you're super excited to get back to math with me, so let's get right to it. All right, this is some GCF practicing. If you were with me this morning, you should be well versed again in this after the break. That's what we spent this morning doing. Go ahead and just factor those real quick, those 4 problems. Pause it and do some work. Go. If you haven't paused it yet, you better. All right, let's see if you're doing it right. X's and Y's, both the terms, as I look at them, have an X and a Y. So I know I can pull X and Y out. It's just a matter of how many X and Y. And I'm going to copy my signs down. First term was negative, second was positive. So I look at my X's, there were 3 X's and then 2 X's. So if I'm taking from both, I can only take 2. That leaves 1 X up front, and I took both X's from the second term. If I look at the Y's, there's only 1 up front and 2 in the back, which means I can only take 1 Y. That 1 from the front is gone, and 1 remains in the back. There you go. Second one, 21 and 15. I'm going to copy down that sign in the middle. A 3 is the common thing there. Okay, you're looking for just breaking that down. Hopefully you're going to be able to start seeing them, but if you need to use a factor tree, by all means, they both have that 3. 7 is what's left of the 21. 5 is what's left of the 15. There you go. All right, number 3. Now we're just putting both parts together. I'm going to copy those signs. They're both negative. 18 and 33, if I break those down with factor trees, I'm going to have a 6, 3 there. I'm going to have a 3, 11. So I'm going to pull out that 3. That leaves a 6 on the front term and an 11 on the back term. And I'm not giving near enough space for variables, am I? So let's space that out a little bit. There we go. K, P, M. Now I can see that M's are only on the back and not the other term, so the M's definitely can't come out. There's no M's on the front term to take. P's, I've got P3 and P2. P2 is the smaller, that's all I can take, which means 1 of those 3 is left on the front term. No P's left in the back term, so that one's done. All right, last one here, 42 and 30. You know what, off the top of my head, I'm not sure, so I will factor this guy out. 30, 3 and 10, 42, 6 and 7. Okay, so I know the 6 has a 2, 3. So I know there's a 3 that comes out of both. And you know what, I was about to be done, but I just saw that there's also a 2 in the 10. They both have a 2. In other words, they both have a 6. So I'm going to pull the 6 out. The 2 and the 3 together makes a 6. That leaves a 7 out of that 42. Copy the signs. And out of the 30, if I take a 6, leaves a 5. All right, they both have X's and Y's, so I know I can take some. 3 X's up front, only 1 X back here, so that's only 1 X I can take out of both of them. That leaves 2 of the X's up front, and that 1 X is taken out of the back term, so he's gone. Y's, I've got 3 and 4, so obviously that's 3. Hopefully it's getting obvious to you. Leaving 1 Y up front, no Y's in back, and we're done. Let's move up that parenthesis, because he looks kind of ridiculous way back there. All right. There's some GCF practice, which, trust me, you want to have. Important for your math. All right, now some FOIL. Maybe we didn't do any FOIL in class today, but FOIL is, number 1, important on its own. Number 2, important to this next factoring method we're going to learn. So let's review it real quick. I'll do one, and then you do the rest. Remember, FOIL has got the F, the first term, right? So the first of both, x times x, x squared. And notice here, parentheses, they're telling us to multiply both of these. So from here on out, if you see a problem like this, you need to know, if you see that it's a FOIL problem. The parentheses say multiply, and there's 2 terms in each parenthesis. So that's binomial times binomial. That means 4 things have to be multiplied, thus our FOIL method. So make sure you start recognizing, if you see that, oh, that's a FOIL problem, that's what I need to do here. So first, we got O for outside, so that means do the outside. X times 3 is 3x, so plus 3x. And now we're done with that front x. Okay, he's been used. We've made sure to distribute him to both parts. Now I've got I for inside. Hopefully this is totally review for you guys. Inside right here. Negative 4 times the x is a negative 4x. And we've got L for last. Right there, negative 4 times 3, negative 12. And notice at this point he's also been double distributed. He's done, so everything has been multiplied with everything. Look for any like terms. You're going to see always that middle one is like in this type of problem. So that's 3x and negative 4x is just negative 1. But we're going to get in the habit of not writing the negative 1. Just put negative x. There you go. Pause it. You're going to do the other 3. Go. Seriously, if you didn't pause it yet, I'm going to crawl through the screen. I swear. Pause it and do the practice problems. All right. I'm coming behind you right now. You should be done if you're watching this. Okay, I'm going to go a little quicker because I've already talked through it. So now we're just going to do the math. X squared minus 7x plus 5x minus 35. There we go. There's our FOIL. Put together my like terms. Negative 7 and 5 is a negative 2x. And there you go. Okay, do it again. There's my front 2, the x squared, and the minus 7x. There's my back 2, negative 5x, and a plus 35. Huh. It's amazing to me. I just used the same set of numbers and didn't even notice it when I was coming up with practice problems. All I changed was a sign. But you know what? We'll take these lemons and we'll make some lemonade. Notice, guys, the difference in these problems. I got a negative 5 and a negative 7 on number 2, and number 1 a positive 5 and a negative 7. So the only difference is the sign on that 5. He's positive. And notice how it changes your answer. We end up with a negative 2x versus a negative 12. So it's going to change your answer. Those signs matter because you're adding different signed numbers. And it changes the sign on the back as well. So those little details will matter. Watch that sign. All right, last one. Let's keep going. Negative 6x squared plus 8x minus 15x plus 20. Okay, not any harder if we add a coefficient on those x's. Same idea. 8 minus 15 is negative 7x, and there you go. Okay, I'm expecting you to be getting proficient with both GCF factoring from the last page and FOIL of binomials, multiplying binomials on this page. You should be proficient with both of these by now. Okay, let's move on. All right. We're actually just going to spend the rest of the lesson today with a little math game. This math game is going to greatly assist us in learning our new factoring method, which is called trinomial factoring, okay? This game is going to build a skill that really is the core of factoring. If you learn this skill today, you already know the factoring method. I just have to show you how to plug it into the actual numbers tomorrow, the equation, okay? So what you're looking for is a pair of numbers that will add to a certain number, a certain value, and at the same time multiply to another given value. So I'm going to give you two values, and it's like a little number puzzle game. And frankly, to be honest, I know I'm a little bit of a nerd. I'm a math teacher, but I really enjoy this factoring method. It's just straight up fun. I enjoy doing it. So let's try it. I'll show you. I want to find two numbers. Okay, so my answer is just two numbers that are going to add to 1, and at the same time they'll also multiply to negative 12. When I think about that, I could start with numbers that add to 1. If I'm not sure where to start, well, let's see. And by the way, remember, we can use negatives. So that makes it kind of easy because 3 and negative 2, those add to 1. Or 4 and negative 3. Or 5 and negative 4. Now, if you see the pattern here, we could go forever and just keep adding 1 to both of those sides. Make them 1 greater on the positive, 1 more negative on the negative, And that would go forever. So we do not want to try and solve these puzzles by starting with the addition. We want to start with the number that they're multiplying to become, because there's very few things. We go back to our factor tree. What multiplies to negative 12? And actually, let's not call it a factor tree. Just come up with the pairs of factors. Don't look at it as a tree. So like 1 and 12. And for now, ignore the sign. Just work on the number. We've got 1 and 12. We've got 2 and 6. We've got 3 and 4. And really, that's it. As far as whole numbers go, that's all there is for factors that'll multiply to a 12, a pair, two things. So now we've got it. That is our answer right there, one of those pairs. As soon as we figure out which one of them also adds to 1. Now the only thing to remember is there's a sign here. So to make a negative 12, we've got to add a negative sign to one of these guys. Okay, it could be negative 1 times 12. That'll work for the final answer. But notice, it could also be 1 times negative 12. So to remember your integer multiplication, one of the numbers is a negative when the product that they multiply to, and remember that's a product. I'm going to use that the rest of the lesson, so make sure we're clear on that. When you multiply, the answer is a product. Okay, so when you multiply two numbers and the product is negative, the sign can be on either one. It doesn't matter if it's on the bigger or the smaller number. So we're just going to figure out which way it works best to make this 1 happen with addition. So if I try, I'll just start here, 1 and 12. No matter where I put the sign, the 1 or the 12, are they going to possibly add to 1? Nope. They can add to negative 11. They could add to positive 11 if one of them's negative, but that's not going to work. So it can't be that one. How about 2 times 6? Well, I can try the negative here. That'll make a 4. Nope. Negative here. Now it just makes negative 4. Nope. Go to the next one. 3 times 4. Well, if I want the answer to add to a positive 1, that means I should make the smaller number the negative. That'll make the answer positive, and hey, there you go, it worked. The pair of numbers that adds to 1 and at the same time multiplies to negative 12 is a 3 and a 4, or negative 3 and 4. And that's it. That's the game. You just look at the factors and figure out which pair will add correctly, and then play around with the signs to make the signs work out. I'll show you again real quick. It adds to negative 6 and multiplies to 5. Oh, well, geez. How many factors are there to 5? 1 and 5. Hello. Can't get any easier than that. All we got to do is figure out the sign. Okay. Now, this is the other type. I've given you an example of each type here. Since we're multiplying to a positive number, in other words, the product on this one is positive, then either it can be positive 1 and positive 5, or negative 1 and negative 5. Because remember, when we're multiplying, a pair of negatives, when you multiply, they cancel out. Okay, that's going to equal positive 5. So the way this game works, what's kind of the fun behind it, is if you happen to have a positive number you're multiplying to, both numbers can be positive or both can be negative. Okay, either way works. So we know it's 1 and 5. We just have to figure out the signs, and here's where we look. They're adding to a negative. So hopefully you've already worked ahead of me. Hopefully you've looked, and it's common sense. If they're adding to a negative, it must be the negative version of both numbers. So what figures out this number game is it's negative 1 and negative 5 makes both of those true. Okay? Now, this is just, I got ahead of myself on the last page. This is just repeating again what I just told you. So I'll go quickly through this, but it's here for you. A negative product, okay, so multiplying, you get a negative number. It means either one or the other of the two numbers is negative, okay? So if I'm looking for two numbers here, I can already tell if it's multiplying to a negative, one of them has to be negative, one of them has to be positive. So we just factor. Now, this 12 we just saw a minute ago, but notice what it's adding to is a different number, which tells us it has to be a different set of factors, or the sign's got to be in a different place. Something's a little different, but we know those are our three sets of factors, and this time they add to 4. So the question is, we just go through 1 and 12, regardless of if I put the sign on the 1 or on the 12, they're not going to add to 4, okay? They're 11 units apart. They're going to add to a 13, or if the sign is negative on one of them, they're going to be a positive negative 11. It's just not going to work. 6 and the 2, if one of them's got an opposite sign, oh, they will add to a 4. See, the 3 and 4, they're only 1 unit away from each other, so those can't be it. In the 1 and 12, they're 11 units away from each other, but the 2 and the 6 are 4 units away from each other if one of them is negative. So that's got to be it. Now we just got to figure out where does the negative go to make a positive answer. It's got to go in the smaller number, like it's on the 2 right now. So we're going to have a negative 2 and a positive 6. Those make it work, okay? Now, in case I'm talking a little too much, let's just streamline a little bit on this last one, okay? Because I know I can overtalk it sometimes. This last one, remember, if it's a positive product, so our 21 here is positive, that means both your numbers can be positive or both can be negative, so just keep the signs the same and it'll work out. So 21, I'm just looking for my factors. That's really all there is. Hopefully it's obvious. It must be a 3 and a 7 to make a 10. And so I just asked myself, 2 positives won't add to a negative 10, but 2 negatives will. And there we go. There's my pair. All right. Why don't you guys try these? And remember, start with the factors per the product, which means you should start by factoring that 20. And then remember, if it's a negative product, that means they're going to be mixed, one of each. If it's a positive product, like your first one is here with 20, then you know they're going to both be the same sign. You'll have 2 positives or 2 negatives. And by the way, hint, hint, all you got to do is look at what they add to. If they add to a negative, you're clearly going to need 2 negative numbers. If it's like this one, 14 means they're both the same sign when you multiply. The 9 they add to tells you they must both be positive. They're adding to a positive number. All right, pause it and just do number 1 and then unpause it. And let's see if you've got the idea. Go. All right, I'm just going to do number 1 real quick and help and see if you're on track. 9, I'm just going to jump to some pairs that probably work. 1 and 20 is always possible, but there's no way that's going to make a 9. So I'm going to look at maybe just 2, 10. 4, 5, and just see how those work. Right off the bat, I'm saying, oh, 4 and 5. If I add those together, they make 9. If I make them both negative, that'll work because the signs cancel when they multiply and make 20. When you add them, they add to negative 9. And by the way, maybe I should have even written this out. I didn't do that on the last couple of pages, guys. That's what we're saying. If I multiply them, they're going to get that number. And if I add them, they're going to add to the other number. So they work. All right, pause it and do the rest. Go. All right, let's try it and see. 18, it's going to be a 3, 6, or it's going to be a 2, 9. I'm going to try those first. They add to a 3, and the sign on the 18 is negative. So I know one of them is going to be a negative number. And so when they add together, they're going to cancel each other. Good guys, bad guys. So basically, I'm looking for numbers that are 3 units apart so that when they add, they cancel away. So it must be the 3, 6. And now since it adds to a positive number, the 6 must be positive. There has to be more good guys. Therefore, the negative has to assign to the 3. And if I add those together, they'll add to positive 3. If I multiply them, they multiply to negative 18. Sweet. That one's done. All right, let's try another one. 14. Well, that's super simple. It's 2 and 7. Let's check. That one solved itself. since it's a positive 14, their signs have to be the same. Then clearly to make positive 9, they must be positive 2, positive 7. We'll add to positive 9. That works. And last one, 32. Well, let's see. Maybe it's a 216. Maybe it's a 4 and 8. Those are the only two that I can think of off the top of my head. And they're going to add to a negative 4. So I'm thinking they're 4 units apart. There's going to have to be one negative, and they're 4 units apart, so they're going to cancel. So I'm thinking it's the 4, 8, because when they add and one of them's negative, they'll cancel away to a 4. And since the answer is negative, the 8 must be the number that needs to be negative with a positive 4. Reason for that is when I add these guys together, I end up with positive 4. Check, that's what I needed. When I multiply them, I end up with negative 32. Check, that's what I needed. And that's the game. Once you learn this skill, this next factoring method will be super simple for you. All right, there's your homework. It's got a little bit of everything. It's got some FOIL. You should be able to tell that just by looking at it. Number 2, notice, is not FOIL. It's not even multiply. It is just adding or subtracting of polynomials. Obviously, in this case, subtract. So remember to distribute that negative and then just combine your like terms. 3 and 4, some GCF factoring. And then 5 and 6 more, that number game. Go ahead and pause it, and I will solve all these for you right at the end so you can see what they look like. Go. All right. Can dive in real quick. Negative 3x squared minus 15x minus 4x minus 20. Put them together, negative 19x. There you go. Second one, I'm just going to distribute that negative. I'm going to do it right inside because it saves time. And I've got a negative 8x squared and a positive 8x squared, which actually is just a 0 pair. They're going to cancel out. Then I've got an 11x and a minus 12x, which means I've got one more negative, so that's going to be a negative 1x. And we're going to write it just like that. And then put together my constants. Negative 9 and 17, that's just going to be 8. Okay, GCF factor. First of all, we need some more room. Let's move him out of the way. All right. 3 terms. I'm going to copy those signs first of all. And it looks like a 3 is probably common to all of those. So I'm going to take out the 3 and be left with a 7, a 5, and a 2. Now, to make sure I took enough, check these guys again. Do they have any other common factors? And 7, 5, and 2 do not. So I know the 3 is it, and I got enough taken out. Now I'll look to my variables. They all have a p and an r, so I know I can take at least one of each. There's 3 p's, 1 p, and 2 p's. So 1 is all I can take, and I've got to leave the rest. That leaves 2 here, but the p's are gone out of the middle, and it leaves 1 p at the end. R's, I've got 2, 2, 2. So they all have 2 to give. I take 2 from all of them, and that's it. It's done. All right, number 4. Let's see, 42 is a 6 and a 7. 28 is a 7 and a 4, so there's that common 7. Leaving the 6 up front, leaving the 4. And do you notice, I just noticed as I filled that in, I did not get everything common. There's another 2 I can take out. So 7 and 2, when I pull out a 2 from the 7, 4, I should pull out a 2 there. So the 7 and the 2 is actually a 14 I should take out. And then when I take the 2 out of the 6, it leaves a 3. Take the 2 out of the 4, it leaves a 2. And there we go. Now we've got everything. And there's an x and a y on both terms, so I'll take that out. And that's all there is. Notice the front term has 1x, 1y, so that's all I can take. So I've got to leave 3 of the 4x's and 3 of the 4y's on that back term, and that guy's done. That's it. Okay. Last, let's dial these. Start with that. 9 is going to be either 3 and 3 or 1 and 9. And since they come together to add to an 8, I bet the 1 and 9 are it. And now I'm just looking at my signs. It was a -9, which means one of them's negative, one of them's positive, and it adds to a negative number. So I need that 9 to be the negative, because I need it to add to a negative number when it's done. And there we go. And again, if anybody's unclear, we're just saying this. They do add to the -8. And they do multiply to the -9, so it works out. Okay, the 25. Well, again, that one's pretty easy because it's 5 and 5. And since it's a positive 25, they just have the same sign, and they multiply to or add to a -10, so they must be both negatives. That's it. It works out. Those are my two numbers. All right. See you guys.